Hello everyone, welcome to CodeChef. Myself Jala Charasi and today we are going to solve the problem which came into starters 211. The name of the problem is no doubling and the problem code is no doubt. The difficulty rating of the problem is cakewalk and the prerequisite is ad hoc. Let's start with reading the problem statement over here. So guys, problem says for an array A of length n, we define f of A as follows. Let S denote the sum so far and H denote your happiness. Initially S and H are both 0. Then for each I from 1 to n in order, if S doesn't double upon adding A of I to it, add 1 to your happiness. That is, if S plus A of I is not equal to 2S, add 1 to H. Note that if S plus A of I is equal to 2S, hold instead H doesn't change. Then add A of I to S. F of A is then defined to be an value of H. To see an example of f of A being computed, we can see the example below. So you are given an array A, A1, A2 till A of n of length n, and you are allowed to freely rearrange this array however you like. Find any rearrangement of A that maximizes f of A. If there are multiple rearrangements that maximizes f of A, any of them will be accepted. Input format: the first line of input will contain a single integer t denoting the number of test cases. Each test case consists of two lines of input. The first line of each test case contains a single integer n, the length of the array. The second line contains n space separate integers a1, a2 up till a of n. Output format: for each test case, output on a new line n space separate integers denoting the rearrangement of A that you found which maximizes f of A. If there are multiple possible rearrangements, any of them will be accepted. Constraint for t lies from 1 to 10 to the power 5, for n lies from 2 to 10 to the power 5, and a of I lies from 1 to 10 to the power 9. The sum of n across all tests won't exceed 2 times to 10 to the power 5. So guys, now let's understand the sample test case in the question. What we said over here. So guys, this question is pretty much straightforward. It says that for an array A of length n, we define an f of A as follows. So let S denote the sum so far. So S would be the sum so far. Initially S and H both are 0. Okay, so then for each I from 1 to n, okay, if S doesn't double upon, let's say if S, that is the sum, doesn't double upon adding up to of A of I to it, so we can add 1 to the happiness, that is the H, right? And note that S plus A of I equal to 2S holds, instead H doesn't change, right? So then we will add A of I to S, right? So if S plus A of I is not equal to twice of S, then I will add 1 to the H. If it is equal to 2S, we don't do anything, we do this. We will add A of I to S. So we have to find an arrangement such that f of A is maximized. Okay, now let's take the first test case. So in the first test case, over here, we over here we this is the first test case. Okay, so you can say that the first test case is 0. Okay, 0 0 0 over here according to this. So from this, I can simply say that the only possible rearrangement would be like 0 0 0. There can be many possible arrangement, right? So from this test case we can say output is 3, and let's go for another test case. It would be more better case, right? So let's consider the rearrangement A is equals to 2 comma 3 comma 1. From here I think you can see from here. Oh wait, okay. Yeah. So for the test case 2, let's consider the rearrangement A equals to 2 comma 3 comma 1, and if f of A is computed as follows. Okay, wait, I think stop. Oh wait, yeah, okay, let me change the test cases, guys. I think the test cases here is not correct. Okay, cool. Yeah, I think this will be more pretty much clear with these test cases. Okay. Hmm. Okay, so I think we are with the right test cases now. Those test cases are not matching. Okay, so we have got the test cases, right? For the first test case we have got 1. Okay, so for that length, and we have got 6 in the array, right? Basically in the array 6. So there could be this same arrangement, there could be no other more arrangement than directly representing 6, right? So this would be the output 6. Okay, and for the second test case, look carefully how we are doing it. Okay, so the second test case is, I will write it over here itself. Let me write my second 2 1 3. Okay, So this would be my second test case if I increase the size weight. Yeah. So we can say that, so we will consider the rearrangement of this such at 2 comma 3 comma 1 times of a. We can compute it like what? So let's say initially s of s is so we know that let's start with the computation. Okay, so let's not drawing once again. Yeah. Okay, so initially s is equal to 0 and h is also equal to 0. Cool. We all know that. So if let I is equals to 1, since s plus a of 1 would be equal to 2, which is not equal to 2s, which will tends me to 0, and we can add 1 to h, and then we add a of 1 to s. Now s will become equal to 2 and h will become equal to 1. If let's say I is equal to 2, since s plus a of 2 is equals to 5, which is not equal to 2 of s, which is equal to 4, we add 1 to h and then we add a of 2 to s, right? So now we will add s equal to 5 to h equal to 2. So let's say if I equal to 3, since s plus a of 3 is equals to 6, which is not equal to 2s is equal to 10, we add 1 to h, then we add a3 to s. Now s equal to 6 and h equal to 3. So the final value of f of a is this, h is equal to 3, and it can be proved this is optimal. Okay, so this could be one of the arrangement, right? So if I take the right outputs from here, let me take it. Okay, so let me, yeah. So this is a practically 2 comma 3 comma 1 will give me the arrangement which maximizes the f of a. Yeah. So guys, I think the test cases are pretty much clear. Just don't get confused. These are the right test cases which we have solved. Okay. So now let's move towards a simple solution. So we want to maximize f of a, which is equivalent to maximizing the number of times we encounter the situation s plus a of I not equal to 2s. Note that this simplifies to just s of equal to a of I, s not equal to a of I, right? So that is, we want to maximize the number of times the element we add does not equal the total sum so far. So observe that one simple situation that ensures that the total sum is not equal to the next element is simply when the total sum is very large. In fact, as soon as the total sum exceeds the maximum element of the array, surely every further index will satisfy s not equal to a of I, because a of I is greater than equal to 1, means the sum only keeps growing, and this naturally leads us to think about making the sum large quickly, and which means placing large elements before smaller ones. So let's start by placing the maximum element at the first position of the array. Let m be the maximum element. Next, we need to think about the second position. Note that if a of 2 not equal to m, then we have no issues at this index. Further, after index 2, our sum is m plus a2 greater than m. So all further indices will automatically be satisfied 2, and no matters the other order of elements. This means we will end up with f of a equal to n, which is clearly optional. Note that only time when we cannot enter the above case is when every element of the array is equal to m. In this case, only one rearrangement exists anyway, so just print the rearrangement. Note that this arrangement has f of a is equals to n minus 1 unless n equal to 1, in which case f of a is equals to 1, right? So quite simply, we can say that if all the elements of a are equal, only one arrangement exists. Just print that one. Otherwise, a has at least two distinct elements. Let m equals to maximum of a. Let place m at first position, any other element other than m at the second position, and then arrange the remaining elements however you like, right? So a simple way to implement this without any case work is to place the maximum element in the first position, then all remaining elements in a sorted order. So this is simple observation based solution, guys. Just reiterate, you will be more clear about this solution. Now let's move toward the simple C++ code. So guys, this is my simple C++ code. I took the input for all the test cases as well as my array over here. Yeah, I am sorting all the elements over here. I will place the largest element first, then rest of the elements, and I will simply print them. Okay. And as you can see that, guys, I have got my C++ code right now. Let's move towards my Python code. So guys, this is my similar Python code. I took the input for all the test cases. I took the input for n. I took the input for my array. I sorted them. I took the first element as the largest element and all the remaining elements in sorted order. And the last, I'm simply printing my that array, final answer array, right? And as you can see that guys, I have got my Python code right. So guys, I think the solution, the code and the approach is pretty much clear. Now let's meet in the next video. Thank you so much guys for watching our videos.